Hello guys, welcome back to another episode. Today we're going to solve Geek for Geeks daily challenge, which is shuffle integers. Question is, given an array ARR of n elements in the following format, which is A1, A2, A3, A4 till an by 2, and then again B1, B2, B3, B4 till bn by 2. The task is shuffle the array to A1, B1, A2, B2, A3, B3 till an by 2, bn by 2 without using extra space. So we don't have to create another array, we don't have to do anything else, we just have to shuffle this array. Note that n is even. So we have an array of length say 4. Out of those we have to divide as like half and then merge the second half into the first half as a zip, merging two lengths together. The car do like a zip kind of merging. So that's what we have to do here. For example, let's see the bigger example, which is 1 2 3 4 5 6. Then we have to take 4 into 1 and 2, 5 into 2 and 3, and 6 after 3. Let's move to the approach part. So the first thing that we are going to do is move through half of the array. We have to iterate over the half of an array as we want to merge second half to the first half. So we just have to move to the half of the array part. Let's see the second. Let's iterate over the half of the length. We have array, we divided it into two parts. Iterating over the second half or first half, what we can do is we have to insert 45 in between this. So fifth element in this at the first index, sixth element at third index, and seventh element at fifth index. How it is, I'll just go through the example. So when we insert fifth element, it should look like something like this: 0, then 1, then 2. Then we insert sixth element, it should be at third index because 0, 1, 2 and then third index. When we insert, what is this? When we insert 75, it should be at fifth index: 0, 1, 2, 3, 4, 5. So if we see, as we iterate over the each element, fifth, sixth, seventh, I just added another example which is 8 to just prove that it is increasing by 2. In other words, what we can say is when we iterate over half of the length, so I have split it into the second part, which is half length. So when we iterate over half length plus I, so if we iterate from 0 till the length 5 plus 0, so half length plus 1, half length plus 0, half length plus 1, half length plus 2, half length plus 3, and so on. For that, we can do is 2 times index, this is 0 plus 1. So 0 plus 0 is 0, and then we are adding 1. So here it is, so as we added half length is our 5 plus 1. So our plus 1 is going to be index. Here this can be achieved by 1 plus 1, which is our index, current index, and then we are adding manual 1. Similarly, here what we can do is, here it is 5 plus 2, which is our current iterator value of I. Here it is 2 plus 2 plus 1. And same thing, it is 5 plus 3, and when we create 7, index 7, that is 3 plus 3 plus 1. So you can see this is our half length value, this is our iterator, and this is our index, which is currently iterator, and then we are just adding 1. So this is what I have written below. So from above example, we can see we have to insert 5 plus 0, which is our index, at index 0 plus 0 plus 1. So we are constantly adding 1. That is what I have written here as well. Let's move to the coding part. For I in range of what, we have to iterate over n by 2. So let me just get it into half length equal to integer of what, integer of this, and half length. Now once we have half length, we have to add. So to add at index, let's get the number first, number of what, so it is ARR of your half length plus I. So currently it is going to be, so the first iteration it is going to be 0, so we will be getting at index 5, which is your 45. Where we have to add it, we have to add this number at index 1. So how we are going to get 1 is your I plus 0, 1, which is 0 plus 0 plus 1. So in other words, arr dot insert at index what, which is our insert index is 2 into I plus 1, and the element that we have to insert is num, and we have to remove, so arr dot pop at index at, we have to okay, we have to remove it first, because if we insert, the length is going to change. So we will first remove of what, we have to remove this element from this index. Okay, why I'm not taking actually the number, so we can even remove by number, but I am just making sure that if there are duplicates, then we won't, because they have not mentioned anything. So if there is a duplicate, then it may cause the trouble. And at the end, what we can do is, okay, I missed indentation. At the end, we can return our ARR. Let's check if everything is fine, and it is completed. I actually changed the test case to bigger one because the smaller they have. So this one is simple, and it may cause some trouble if we don't look at the longer term, but it is working. Both of the test cases pass. So let me submit it to check if something is failing or not, and all test cases pass. Great. See you tomorrow. Thank you. Bye.